Today we're going to read Multiply on the Fly by Susan Slade. Numbers are an important part of our world. You can find them in school, sports, and nature. When you know how to multiply numbers, you can figure out almost anything. 9 brilliant butterflies twinkle in the dark. Glowing lights flash on and off. How many in the park? So if we have 9 fireflies and each firefly has 1 light, we're multiplying 9 times 1 equals what? Can you figure it out? That is 9 groups of 1. 9 times 1 is 9. 5 lonely grasshoppers sound their mating song. Each strums 2 shiny wings. How many play along? So we have 5 grasshoppers, and each grasshopper has 2 wings. 5 times 2 equals. Is there an easier way to think about that multiplication problem? 5 groups of 2, or we can add 2 5 times and do repeated addition. What do you think 5 times 2 is? Yes, there are 10. 4 lovely Luna moths rest upon a pine. Each one spans 3 inches. How long is the Luna line? 4 times 3 equals. The way that they're lined up, it almost reminds me of an array. Could you draw out 4 groups of 3 as a multiplication array to figure out how long our Luna line is? 4 times 3 equals 12. Good job. 8 daring dragonflies soar into the sky. Each is flapping 4 strong wings. How many wings go by? So if we have 8 dragonflies and each dragonfly has 4 wings, our multiplication problem is 8 times 4. Now that's a harder one. There's an easier way that we can do this problem if we look at it as 4 times 4 plus 4 times 4. That might be an easier way to work it. 4 times 8, you're right, it's 32. Six sturdy soldier ants march around the yard. Each uses 5 small eyes. How many eyes stand guard? Oh, those are some menacing ants, aren't they? So our problem is going to be 6 times 5 equals. 5 is a friendly number, and we like that one. Can we count by 5s to find the answer? 5, 10, 15, 20, 25, 30. That's right. Those ants have 30 eyes. Good job. 4 hungry honeybees dance a buggy beat, tapping with 6 furry legs. How many dancing feet? So our problem is 4 times 6 equals. Great job. 4 times 6 is 24. Oh, we have ladybugs now. 8 little ladybugs wearing 7 spots rest on fragrant flowers. How many small black dots? 8 times 7 equals. That's a harder one too, but we could work that problem if you think about it as 7 times 7 plus 1 more group. We'll work on that one. 7 times 8 equals 56. Good job. 3 helpful pirate bugs start their work at dawn. Each eats 8 spider mites. How many pests are gone? 3 times 8 equals. That's how we're going to solve this problem. How many pests are gone? Great job. 3 times 8 is 24. 7 stealthy walking sticks climb onto a tree. Each has 9 long parts. How many do you see? So to solve this problem, we set up the multiplication 7 times 9 equals. That one's tough too, but we make it easier if we think about it as 7 times 10 and do some mental math strategies. Can you see how we can use 7 times 10 to easily figure out 7 times 9? Great job. 7 times 9 is 63. Six swarms of butterflies migrate in the fall. 10 monarchs in each group. How many fly in all? So this problem requires us to look at 6 groups of 10. But this is an easy multiplication to remember because it's simply 6 times 1 and add a 0. Great job, you got it. 6 times 10 is 60. Two silent spittlebugs find a leafy home and blow 11 bubbles. How many in the foam? I like doing 11s too, my 11 multiplications. Those are almost as easy as the 1s and the 10s. So for this problem, we have 2 times 11 equals. Can we figure that out if we know what 2 times 1 is? What's 2 times 1? Great job, it's 2. So 2 times 11 would be? Great math, 22. I hope you enjoyed reading Multiply on the Fly with me and doing some multiplication problems and using those mental math strategies.
I hope you enjoyed Multiply on the Fly. And now I'm going to look at some math strategies that can be used for multiplication to help when memorization does not come easy. The first thing we need to look at is the multiplication sentence. The first problem in the book was 9 times 1 equals, and we had to find the product. The story talked about 9 fireflies in the dark, and each firefly has one glowing light. How do we set that problem up? Of course we know it reads 9 times 1 equals blank, where we're looking for the product of 9 times 1. But what does that multiplication sentence really mean? I can replace the X or the multiplication symbol with some words and read this as 9 groups of 1. What would the model for 9 groups of 1 look like? Let me first start by showing you the groups. Here I have 9 groups, and in each group I need to add 1 firefly. This is the model for 9 groups of 1. I can easily count the fireflies and their lights and know that 9 times 1 is 9. Another strategy that can help with multiplication is thinking about multiplication as repeated addition. Another problem in the story was 5 times 2 equals. 5 grasshoppers each had 2 wings. How many wings are there? We have to answer the question 5 times 2 equals blank. Knowing that I can read this as a statement, 5 times 2 is the same thing as 5 groups of 2. Is there another way that I could look at 5 groups of 2? 5 groups of 2 is the same as 2 added 5 times, which looks like this. 2 plus 2 plus 2 plus 2 plus 2. If we add all those 2's, we have the sum as 10. Multiplication is the same thing as repeated addition. So I know that 5 times 2 equals 10. I can also think of multiplication as an array. We had to find out what the product of 5 times 3 was? 5 times 3 equals blank. I know that I can think of that sentence as 4 groups of 3. Can I arrange my moths in an array showing 4 groups of 3? Here is my first group of 3, my second group of 3, my third group of 3, and my fourth group of 3. This is a 4 by 3 array where I have 4 rows showing my 4 groups and 3 columns showing 3 moths in each group. I can easily count the moths and know that the product of 4 times 3 is 12. Sometimes it's easier to decompose into a friendly number to do my multiplication. 8 times 4 equals blank. This is a harder problem to solve, but I can make it easier with numbers that I know their product of multiplication. For example, I can take the 8 in the problem 8 times 4 and decompose that into 4 plus 4. Now I can write a new multiplication sentence where each of the 4's are multiplied by my original 4 and I add the 2 smaller products. 8 times 4 is the same statement as 4 times 4 plus 4 times 4. 4 times 4 is an easier multiplication product to remember because I kind of like the sound of saying 4 times 4 is 16. Now my problem becomes simply adding 16 plus 16, and I know that sum to be 32. I now know the product of 8 times 4 is 32. Decomposing into friendly numbers takes a little bit of practice. Let's try another one. 8 times 6. That's sometimes a harder product to remember, but I learned that I can decompose 8 into 4 plus 4. I can rewrite my multiplication sentence to be each one of the decomposed numbers times 6. So now my statement is 4 times 6 plus 4 times 6. 4 times 6 is an easier multiplication product to know. 4 times 6 equals 24. So now my statement can be rewritten as the sum of 24 plus 24. 24 plus 24 equals 48. So now I know that the product of 8 times 6 is 48. One of my favorite ones to do, and I think the easiest, is counting by fives as a strategy for multiplication. What is the product of 6 times 5 to find the number of eyes that are standing guard in our ants? 6 times 5 is simply 6 groups of 5. Can I count by fives to find the product? Count with me. 5, 10, 15, 20, 25, 30. As you see, I have 6 groups of 5 represented in my count by fives. So I know the product of 6 times 5 is 30. Let's practice the fun one. What is the product of 8 times 5? Now I need to count. Let's practice counting by 5. What is the product of 8 times 5? We can think of 8 times 5 as 8 groups of 5, and then we can count by fives to find that product. Count with me. 5, 10, 15, 20, 25, 30, 35, 40. As you can see, I have 8 groups of 5, so I know the product of 8 times 5 is 40. Another strategy that we can use is called one group more. What is the product of 8 times 7? That one is also a little tricky, but we can make it easier by a multiplication product that we know. If I have trouble with 8 times 7, can I use the product of a multiplication that I know? I know 7 times 7 equals 49. I know that 7 groups of 7 equal 49. What would one more group of 7 be? Because my original question says I have 8 groups of 7. So I need one more group. I can simply add 7 to 49 to show that one additional group. The product of 8 times 7 would be 56. Let's practice one more group strategy. If you have problems remembering the product of 7 times 6, you can use the product of multiplication that you know. 6 times 6 is 36, meaning 6 groups of 6 contain 36 items. What would one more group of 6 be? The original question asked for 7 groups of 6, so I need one more group. I can simply add another 6 to 36 to find the product. 7 times 6. What is the product of 7 times 6? 7 times 6 is 42. One last strategy to look at. This was where we have one less in each group. 7 times 9 can sometimes be a tricky one, but not if we use a very easy multiplication product to help us. If you struggle with 7 times 9, use 7 times 10 as a starting point. We know that the product of 7 times 10 is 70. This means that 7 groups of 10 have 70 items. But what would one less in each group be? What would one less in each group be? If I take 1 out of each group, I would have to subtract 7 from 70 for a difference of 63. Now I know the product of 7 times 9 is 63. I hope you can use these strategies to help you the next time you have to multiply.